Alright, time for the real world systems of equations problems, basically word problems for systems of equations. What I would like you to do on each of these is, I'm not going to spend time like reading the situation. I'm expecting you to just do that, and so when you get to these, you can pause the video and read it, make sure you know what's going on. Anyway, so as you look through this one, notice look for numbers, and you should probably highlight those. And when we're going about this, we need to write a system of equations that'll describe what sort of constraints are happening with this. And one of them is you work in the maximum number of hours, which is 29. And so that's a total. Your hours are going to add up to be 29. So we're going to have a couple of things coming out to be 29. And there's two different jobs, and you can work a different amount of hours at each of them. And so let's say the pet walking one is P and the car washing one is C. The number of hours walking pets plus the number of hours washing cars will give us 29. That's going to be the total. And so I'd make a note here that P is going to be the number of hours walking pets, and we'll say C is the number of hours washing cars. Okay, with the system of equations, you're gonna when you have two variables, you need at least two different equations to solve it. And so I need another equation, and this other one's going to come from my total here. It's another total. You get $189 with those 29 hours. Well, I'm not going to use just P and C because that's just the hours. I want to get the wage from each of the hours, from each of the different jobs. The total is going to come out to $189. But the pet walking one pays $7.50 per hour. So if you do $7.50 times the number of hours, that'll give you the wage from walking pets. And washing cars is $6 an hour. And if you take 6 times by the number of hours, that'll get you how much you got from washing cars. So here's our system. It lists those constraints, but in numerical form and in equation form. And from this, you can solve and get yourself an answer on how many hours you did for each. So let's get started. I notice here that I can actually solve for one of those variables rather quickly, and that can make my job a little bit easier. I'm going to solve for C, just because I know that my variable and my coefficient on P on my other one, 7.5, it won't be really easy to distribute. So I'm going to subtract P from both sides on this first guy. To get C, the number of hours washing cars is equal to 29 minus the hours spent walking pets. And so I can take this, what C is, and put it into my other equation. And that'll give me, that'll replace the C's with just things with P's in them. And I actually can help us solve this by substitution. So now this, 189. Now I need to distribute this 6, distribute it through. I got 7.5p plus, well, I don't know what 6 times 29 is. Here, let me use my handy dandy calculator. That'll give me 174, and then minus 6p has to equal 189. Now let's just subtract the 174 from both sides. And while we're at it, let's combine like terms here. 7.5 and negative 6 are going to combine to give us 1.5p. On the right side, we're going to have 515. Now I just need to divide both sides by 1.5. And I will get p equals 10. And now that I know what p is, the number of hours spent walking pets, I can take that number, plug it back into my other equation to get, let me fish this way, plug it into my other one to get C equal to 29 minus P, which is just 10, and so C is going to be 19. C19, P10, we'll get 10 hours walking pets, 19 hours washing cars. So there's that one. Let's move on to 2. So buying plants and stuff. This one did have a typo. It was supposed to also include that Marcia gets twice as many plants as, twice as many bags of soil as plants. Here, let me add that in. There you go. Now we have that in, because that will be an important part in trying to actually get an answer out of this one. So, as you search through the situation, look for things like, well, first figure out, like, what you're trying to get, which is how many of each item she got. Well, she can get 2 different items. She can get bags of soil, and she can get plants. And so let's use B and P as our 2 variables, where B is the number of bags of soil, and P will be the number of plants, because that's what we're trying to get to. So let's make our variables those numbers, and then we can make our system from that. So here, look for constraints. Look for something that tells you the relationship between the numbers. And one easy way to do that is look for totals and then like rates. Here, Marcia spends $108, and that's a total. That's like how many dollars she ends up spending. Well, if you want to figure out how much she spends, you have to figure out the cost of each item and times it by how many of that item she got. So if you want to figure out the cost of the bags of soil, that's $4 per bag. You take 4 and you times by the number of bags. If you want to get the cost of the plants, you take 10 and you times by the number of plants. And the number of plants and the number of bags of soil aren't determined at this point. We don't know what they are, so we're going to use the B and the P. Another constraint is this in this new statement. If you get twice as many bags of soil as you do plants, what do we know about the relationship between bags of soil and plants? Is the number of plants twice the bags of soil, or is the bags of soil twice the number of plants? It's the second one, okay? There are twice as many bags of soil as there are plants, and so the bags of soil would be double the number of plants. Okay, so there's our system. We actually have it right here. And I'm actually going to rewrite that on this next screen so we have some room to work with it. So now I have my system here, and I'm actually already set up for substitution because B is 2P. I'm going to substitute that in for B right there. And I'll get 4 times 2P plus 10P equals 108. Make sure you distribute that, or just times it through. You get 4 times 2 gives you 8. So 8P plus 10P is going to give me 108. Combine those to get 18P equals 108. And now I just need to divide both sides by 18 to get P by itself. And I'll get P equaling, I don't actually know that off the top of my head, but I think it's 6. Yep, 6. So the number of plants that she got was 6. And I can take that variable and plug it back into my equation here. So B equals 2 times 6. So the number of bags of soil, which is twice the number of plants, is going to be 12. So we get 12, 6 as our point here. And let's do one more. So read through and make sure you notice the important information here. So in this particular situation, there's actually a couple ways you could set up your variables. One way is to have our variables be like S, and I'm going to do a little b, for the number of small boxes, as in boxes that have small books. And then I'll do big B for number of large boxes, meaning the number of boxes that have large books. That's one way to set it up. It's like counting the boxes, or you can have little b be number of small books, and big B equal to number of large books. And depending on what you choose, you'll get different situations. And on this particular one, I'm going to use this first option rather than the second one. And you'll see why in just a little bit. Because it actually makes it really easy to write our system because we have this statement here that there's 11 boxes. So I already have a total here, 11, and it's just the number of boxes with small books plus the number of boxes with large books. And that just gives me my total there of 11 boxes. And it also is helpful in writing out the total number of books. So there's 130 books, and the way you figure out the number of books is you take your number of large boxes, or boxes that fit large books, and you just times that by 8. And you take the number of boxes that have small books, and you times that by 15. And this system is actually fairly easy to set up if we're counting boxes. And realize that small b and large b are the number of boxes, not the number of books. So we're gonna have to change our answer a little bit at the end there. So be aware of that. If we set it up the other way, our system would look something like this instead. Which, you know, if you're all for doing division, that's fine. You'll get the same answer either way. Anyway, so I'm going to use this first one rather than the second one, even though the second one would be right. So I'm going to copy that over onto the screen so I have some room to work. So now I have my system here, and what I'm going to do is we're actually really close to having it set up for substitution. So I'm going to just take this first equation, and I'm going to subtract little b from both sides. Make sure you don't mix up your big B and little b if you're using b's like I am. Anyway, that's going to give me large B equals 11 minus little b. And I can take this and substitute it in for the large B in my other equation. So I have 15 little b plus 8 times 11 minus little b equals 130. Just distribute that through. We'll have 15b plus 88 minus 8 little b equals 130. And let's subtract 88 from both sides. Let's get the b's all by themselves on the left side. And we're actually going to combine like terms while we're at it. So 15b minus 8b gives me 7b. And on the right side, if you take 130 and you subtract 88, you'll get 42. And divide both sides by 7, you'll get little b, or the number of boxes that hold the little books, coming out to be 6. So there's that, and I can actually take this number now and plug it back into that equation right there. So the number of boxes with large books will be equal to 11 minus the number of boxes with small books, which is 6. So that's going to be 5. So these are the boxes, number of boxes, not the number of books. If you want to switch, transfer it to the number of books, you have to do 15 times b, or 15 times 6. And I wish I could write this better. If you do 15 times 6, it's going to give you 90. And you just take 130, subtract out the number of small books, 90. And that'll give you 40, which is the number of large books. So 90 small books, and then 40 large books. So be very aware that large B and little b aren't the number of books, they're the number of boxes.